Okay, so what you would have had for that diprotic acid, you'd have H2SO4 plus KOH, and then you're going to get 2 waters, and then you're going to get a K2SO4. Questions with that? And these could be aqueous.
Will you have to put a 2 in front of the KOH on the left side to balance it?
Yes, you do. Okay, so when you do these problems, the ones I give you to do did not have any diprotic acids in there, and so you can do those right and then get these wrong if you don't set them up correctly. So we'll just do an example of a titration of a H2SO4. Okay, so this question would be like, determine the concentration of 20 milliliters of H2SO4 if 42.5 milliliters of 0.25 molarity NaOH is required to neutralize.
Would it be KOH for this one?
Yeah, I'll just change that to KOH. Okay, so we'll just change that to KOH. Alright, so you can do this all in one step. The book kind of divides it up in steps, so I'm going to do it all in one step. And so what I know is I know how much of the KOH I have. So up here, I know that I have 42.5 milliliters of it, and I've got 0.25 molarity. Okay? So then what I can do is I can find the moles of that. Okay? And so instead of showing the ice, which if you guys want to do it that way, you can. I think I'll show it both ways, and then you guys determine kind of which way you want to go. So I'm going to go ahead and start out this way. I'm going to go ahead and I'm going to automatically put as 0.0425 liters. So I went ahead and converted milliliters to liters, and that's of KOH. Next thing I'm going to do is what you guys normally do up here that I showed you with the ice. You found the moles of the KOH. And you did that by multiplying the 0.0425 times the 0.25. When you multiply it, you're going to get initial amount down here that would be 0.0106. So there's 0.0106 moles of this. So that's what I do on the first step. So down here, when I do the liters, down here I'm going to put for every 1 liter, I have 0.25 moles of NaOH. And this is liters of NaOH, or KOH. So the KOH cancels and I got moles. So now I have moles, and that's what the value is right here. Okay, so it wants to know the molarity of this solution. So I want to know the molarity of H2SO4 concentration. Okay, so now what we do is we do a middle step, and it's a mole-to-mole ratio. So what's the mole-to-mole ratio? How many moles would we have to have of H2SO4? So if we were doing the ice, we would say 0.0106 moles of KOH. We'd have to have half as much of H2SO4, right? So that is 0.0053. Does that make sense? Okay. So that step is right here. If you show the longhand version, what you would do, you say for every 2 moles of KOH, I have 1 mole of H2SO4. So the second step I did was with the ICE, and you kind of realize you have to take this divide the 0.0106 divided by 2, and then multiply by 1 to get to 0.053. That's what we're doing on this step right here and below. So I'm showing 2 different versions of how you can do this. Then since I have moles of H2SO4, and I want to find the molarity of it, all I have to do then is divide by the volume of the solution, which is 0.020 liters. And that's of the H2SO4. So I'm just going to put like 1 over that. And so I've got moles cancel. And then I got moles of H2SO4 over liters of H2SO4, and that's my concentration. If you use the ice, then at this point you just take the 0.053 moles of H2SO4 and you divide it by the 0.020 liters, and you get the same answer out. Okay? And that would be the concentration.
So is there one way that you prefer us to do?
Nope. I don't care which way you do. If you're used to using ice, and you can kind of see that how that all works out, you can do it that way.
So is ice is just, it's more handy when there's a limiting reactant, or?
Yeah, it's really helpful if you have a limiting reactant. But you can do all ratios with ice. You can figure out all ratios with ice, and it's just a way to show it that's connecting it within the equation versus just writing out your units and canceling them out. So I'm going to let you guys do a little titration today just to kind of see what that's all about. Kind of remember how to do that. By the way, this concentration would be 0.265 molarity H2SO4. And so that would be the strength of it. Now, so when you titrate, you get these numbers. So, like in this example up here, it took, if I titrated it, it took me to do this reaction, it took me 42.5 milliliters to do the reaction. And so that allows me to get all my numbers in that.